All right, so we are simplifying some complex number expressions. Some we're adding, some we're subtracting, some we're multiplying. So this first one, we're just multiplying. And so you treat I just like a variable. 3 times -2 is -6. I times I is I squared. I squared is the same thing as -1. -6 times -1 is +6. Over here, we're adding, and so we're basically just combining our like terms. We have 3 plus 3, which would be 6, and then 2i plus -2i would be 0. And so this simplifies just to 6. Here we are subtracting, so it's best to go ahead and distribute a negative and ignore the parentheses. And so no parentheses now that we've distributed the negative. And then when we combine our like terms, our real parts are -3 and -5 for -8. And then the imaginary part is 2i minus 6i, which is -4i. And so our final answer is -8 minus 4i. This next one, we are multiplying, and so it helps to organize it using a box rather than just FOIL. And so 4 plus 5i, and then 4 minus 5i. You have to write the negative. And so 4 times 4 is 16, 4 times -5 is 20, and then there's I. 5 times 4 is 20. With the I, 5 times -5 is -25, and then I squared. Okay, I squared is the same thing as -1, and so we can write that as -1, and then -25 times -1 would be +25. And so the reals are 16 plus 25, which is 41. And then the imaginaries cancel. 20 minus 20 is 0. And so our final answer would be 41. Okay, here same thing, but we can do some simplifying first. Because there's a negative under the radical, we're going to take an I out of each one. And just rewrite this as complex numbers. And so now when we make the box, we have 2 minus I root 3, and then 5 plus I root 3. 5 times 2 is 10, 2 I root 3, -5 I root 3, -I squared. Root 3 times root 3 is root 9. And so this last box, I squared is the same as -1. Square root of 9 is the same as 3. And so I have -1, which cancels to a +1. And so this last box simplifies all the way to a 3. And so the real parts is 3 plus 10, which is 13. And then the imaginary is -5i root 3, and then 2i root 3. Those are like terms, so that would give us -3i root 3s. And so our final answer would be 13 minus 3i root 3. Right, this last one, be careful. You can't distribute the square. This is the same thing as 5 minus 3i times 5 minus 3i. So we still need to FOIL or use box method to multiply a binomial times a binomial. we get 25 minus 15i minus 15i, and then 9i squared. I squared is the same as -1, so we end up with a -9. 25 minus 9 is 16. -15 and -15 is -30i. And so our final answer here would be 16 minus 30i. Okay, next we're using the quadratic formula, and during the process we're gonna find the discriminant and find the nature of the roots and then the solutions. And so the quadratic formula, we need a, b, and c. So a is 1, b is 4, c is 7, and then x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so b goes in the first two blanks, a goes in the next blanks, top and bottom, and then c goes in the last blank. And so we can simplify this to -4 plus or minus square root of 16 minus 28 all over 2, which is -4 plus or minus -12, square root of -12 over 2. And so the discriminant, the number under the radical, is -12. And so because it's negative, the nature of our roots are going to be complex. And so now we can simplify further by taking an I out. And then we can simplify square root of 12 to square root of 4 times 3, which means we can take a 2 out as well. So -4 plus or minus 2i square root of 3 over 2. And then we need to divide the numbers outside the radical by that 2. And so this simplifies all the way to -2 plus or minus 1i square root of 3. So we have -2 minus I root 3, and then -2 plus I root 3 as our two complex solutions. Okay, here a is 1, b is 4, c is 4, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So b goes in the first two blanks, a goes in the next blank, top and bottom, and then c goes in the last blank. And so this simplifies to -4 plus or minus square root of 16 plus 16. Oh, that should have been minus 4ac. And so we end up with a 16 minus 16 under the radical, which means we have a 0 under the radical, which means the whole plus or minus expression goes away, and we have one solution. And so whenever your discriminant is 0, you're going to have one solution that's real and rational. It's always going to be a real rational number. In this case, it's -2. 9, we have a equals 2, b equals negative 3, c equals negative 5, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So b goes in the first two blanks, a goes in the next blanks, top and bottom, and then c goes in the last blank. So x equals positive 3, square root of 9, and then negative 4 times 2 is negative 8 times negative 5 is positive 40, all over 4. So 3 plus or minus square root of 49 over 4. So our discriminant, 49, is a perfect square. And so that means we're going to have real rational solutions. 2 of them. So square root of 49 is just 7. And so we can simplify all the way to these rational numbers, 3 plus 7 over 4, and then we'll do 3 minus 7 over 4. This would be 10 over 4, which is 5 over 2. This would be negative 4 over 4, which is negative 1. Okay, next we're factoring. And so for number 10, we need two numbers that multiply to a times c. And so in this case, a times c is negative 30. And we need them to add to the b value, which is negative 1. And so those numbers are negative 6 and positive 5. And so we split the middle term, so it's negative 6x plus 5x minus 5. And then out of the first pair, we can divide both by 6x. So 6x is the GCF, leaving us with x minus 1. And then for the second pair, we can divide both of those by 5, leaving us with an x minus 1. The x minus 1 matches, and so that's one of our factors, and then 6x plus 5 is the other. Okay, and so these factors are equal to 0. If we set each one individually equal to 0, we can solve for x. So in this case, x equals 1. Here, 6x equals negative 5. Divide by 6, you get negative 5 over 6. And so our solutions are x equals 1 and x equals negative 5, 6. Number 11. A times c is 6, and then we need them to add to negative 5. That would be negative 6 and 1. Nope, that multiplies to negative 6. So we need negative 2 and negative 3. And so we can split the middle term into negative 2x and negative 3x. Out of the first pair, we divide by 2x and get 2x times x minus 1. Out of the second pair, since this first term is negative, we need our GCF to be negative, and we can also get a 3, leaving x minus 1. The x minus 1 matches. So that's one of our factors. 2x minus 3 is the other. set each one individually equal to 0 so that we can solve for x. So in this case, x equals positive 1. Here we have 2x equals positive 3, so x equals 3 halves. So x equals 1 is one of our solutions, x equals 3 halves is the other. Number 12, we need two numbers that multiply to 5 times negative 7, which is negative 35, but we need them to add to 34. And so that would be positive 35 and negative 1. So plus 35x minus 1x. Out of the first pair, we can divide by 5x, leaving x plus 7. Out of the second pair, we know we're dividing by a negative, and then the only other thing we can divide by is 1. So negative 1, leaving an x plus 7, because negative 7 divided by a negative 1 would be positive. And so x plus 7 matches, that's one of our factors, and then 5x minus 1 is the other factor. Set each one equal to 0. And so in this case, x equals negative 7, 5x equals 1, so x equals 1/5. Right here, we need to move the 5 over first by subtracting it. Doesn't combine with anything, so we're just going to write it after the x term. And then a times c is negative 35. And b is negative 2. So those numbers would be negative 7, positive 5. Split the middle. We can get 7x out of the first two. We can get 5 out of the second. And so we end up with x minus 1, 7x plus 5, still equals 0, so each one equals 0. So x equals 1, 7x equals negative 5, and so x equals negative 5/7. Right here, a times c is 18. And then our b value is negative 11. And so that would be negative 9 and negative 2. And so we can get a x out of the first pair, leaving behind a 2x minus 9. We can get a negative and just a 1 out of the second pair, leaving a 2x minus 9. And so 2x minus 9 is one of our factors, x minus 1 is the other, equal to 0. So 2x minus 9 equals 0, or x minus 1 equals 0. In this case, 2x equals 9, so x equals 9 halves. In this case, x equals 1. Last one, we need to move the 8 over. So now it's plus 8. And so A times C is 24, and then B is 14. So we need two numbers that multiply to 24 but add to 14. Need to make a list. 1 and 24, 2 and 12, 2 and 12. So 3x squared plus 2x plus 12x plus 8. We can get an x out of the first pair, leaving a 3x plus 2. We can get a 4 out of the second pair, leaving a 3x plus 2. So 3x plus 2 is one of our factors, and x plus 4 is the other, equals 0. So 3x plus 2 equals 0, and x plus 4 equals 0. 3x equals negative 2, so x equals negative 2/3, or x equals negative 4. Alright, last section, we're completing the square. And so you want your x squared plus x equal to the constant, and then you are going to add a number to both sides. That number is opposite of b, not opposite of b, just b over 2 squared, which is 3 squared, which is 9. And so the left side is going to factor to x plus 3 squared, and the right side is going to factor to 20, or simplify to 25. Using our square root property, x plus 3 equals positive negative 25. And so x plus 3 equals positive negative 5. We can slide the 3 over, changing its sign. And so our two cases is negative 3 plus 5, negative 3 minus 5. So in this case we get 2, in this case we get negative 8. Over here, we need to add a number to both sides. In this case, it's going to be 8 over 2 squared, which is 4 squared, which is 16. And so the left side factors to x plus 4 squared equals 36. So square root property says x plus 4 equals positive negative square root of 36. That's a perfect square. So we can write that as positive negative 6. Slide the 4 over. So it's negative 4 plus or minus 6 to get our cases. Negative 4 plus 6, negative 4 minus 6. In this case we get 2, in this case we get negative 10. Okay, over here, we need to move the 1 to the other side first. And then add in our boxes. This time, b over 2 squared is negative 3 over 2 squared. And since that's a fraction, we're going to square the top and square the bottom, so we get 9 over 4. Okay, and so the left side is going to factor to x minus 3 over 2 squared. And then on the right, we need a common denominator, so we get 4 over 4 plus 9 over 4, which is 13 over 4. Okay, and so for the square root property, x minus 3 over 2 equals positive negative square root of 13 over 4, which if we break them up, square root of 13 over square root of 4, square root of 4 is 2. Okay, and so we're going to move the 3 halves over, so now it's positive, and we have to add that to the square root of 13 over 2. So we have two irrational solutions since square root of 13 can't be simplified. Okay, over here, our a value is not 1, but we can divide each of these numbers by 3 right off the bat. And if it happens to both sides of the equation, we can ignore it. So we have x squared plus 10x minus 2 still equal to 0, because 0 divided by 3 is 0. And then now we can move the 2 over. Make room for the boxes. Half of b squared is 25. The left side factors to x plus 5 squared. Right side simplifies to 27. Square root property. And then 27 is not a perfect square, but we can break it up into 9 times 3, which means we can take a 3 out. And so when we move the 5 over, it's plus or minus 3 square roots of 3. Irrational solution since we didn't have a perfect square. Okay, over here we need to move the 7 over. Make room for the boxes. Half of b is negative 2. Square it, it's 4. Left side factors to x minus 2 squared. Right side simplifies to negative 3. Square root property. And so we're going to have some complex numbers because we're going to take an I out for that negative square root. So when I move the 2 over, it's plus or minus I root 3. That's the best we can do. And then for the last one, we still need to divide everything by 3, even if we don't get nice numbers. And so here we get x squared minus 3x plus 11 thirds equals 0. And then we need to move the 11 thirds over. Make room for the boxes. half of b is -3/2. And when we square it, we get 9/4. So the left side factors to x -3/2 squared. And we need a common denominator for the right side. So if we multiply that by 4, we're going to get, well, and this by 3, we'll have -44 thirds, 12ths, plus 27 12ths. And then we got to figure out 44 minus 27. It's going to give us -17 12ths. Okay, and so I'm going to rewrite that down here. X minus 3/2 squared equals -17 12ths. And then square root property. And then we can move the 3/2 to the other side. Break these up into their own square roots. For the top, we get I square root of 17. For the bottom, we can take a 2 outside the radical and get square roots of 3. And technically we should rationalize the denominator, but you're not going to have to do that for the test, so you can leave your answer just like this.